I'm Martín Torrado. I'm part of the ArtEdge support team, and I will talk about the new flavors that Evolution 3 is introducing for smart devices, and this is the offline modality. Let's start with basics. What do we mean by offline? We'll talk about partially connected or disconnected applications, autonomous applications that will work at any time. For example, if I'm walking along the street with my device and I'm using my application and I lose the internet connection, the application will keep on running. And when I recover connection, it will connect once again with a centralized server database and will generate a process that we call synchronization process. And we're going to talk about this later. So we talk about offline applications. These are applications that access local data with the possibility of executing complex logics with a device. Why do we do these applications? We do them. One of the reasons is because sometimes we find scenarios where we have limited or no connectivity, and we need to generate robust applications so that they keep on running in those scenarios. Therefore, we will be using Evolution 3 for more complete and functional applications. And something that's very important for us, GeneXus developers, we have a new window of opportunities where offline is not only no longer desirable, it's a requirement in the system. So you may wonder what examples we have. I brought you Prolixus Mobile, which is a Salesforce application, which clearly reflects the need to have this offline modality. Why? Because my salespeople will go out, they will carry their tablets or cell phones, and when they generate a sale, they would like to register that sale, whether they have a connection or not. The sale should never depend on connectivity. So this is a very clear example of why this is a new requirement. Another application is MetroDF. This is an application that provides information on lines, stations, transshipment stations for the Mexico City Metro services. This application will calculate the best connections. It will show me maps of the stations in an offline manner. Why is this important then? Because as a user, I will be in a sensitive area to connectivity like a metro tunnel, and I don't care whether I have connectivity or not. I just want to go how to get to a point of destination. So if I want to use this in the metro station, I need this kind of application. This works offline. So we are at a turning point. We need to wonder, are we ready to develop applications for the new scenarios? That's a question you should ask yourselves. I myself want to say that thanks to GeneXus Evolution 3, we are more than prepared to prepare first-level applications. So you are welcome to try Evolution 3 and to evolve your applications to the new offline modality. You have not left my presentation, so I will delve into more details. Let me talk about the architecture of these apps, and then I will talk about other things more in detail. So in order to understand architecture, we should start with what you know. This is the architecture of all applications online up to Evolution 2. If you remember well, we had a device with the installed application which connected through Internet with a centralized database through REST services. It connected to obtain data for that application and to do actions of insert, update, delete against the server's database. Now, when I lose connection to the Internet, connecting these two worlds, what happened was that the application became just a reading operation. If the cache was working, it could read data, but it could not act against the server's database, and it could only read the data that were loaded. So With the new architecture, GeneXus Evolution 3, which is an offline architecture, many things are maintained, but others change. One of the things that changed is that we will be creating a new database on the side of the customer. This database is SQLite. That's an engine for database. It's free of charge. It's pre-installed in Android and iOS. And this allows us to access local data in our device. Having a database on the side of the customer and accessing local data generates much more complex processing for the device. Sorry. Now, to process this, we will be generating programs in native code in the different platforms. It could be in Android, it will be programs on Java, and the other ones will be changing accordingly. So this database on the side of the customer and the database on the side of the server, are they independent? No, they are synchronized somehow through a process we call synchronization, and I will talk about this later. I also want to say that in the new architecture, the start, refresh, and reload events will take place on the side of the customer by accessing local data and not on the side of the server as in Evolution 2. Now, everything will be interpreted. If these are offline objects, they will access local data. They don't need to go to the server. So how do we do this with GeneXus? We have a new property called connectivity support. Connectivity support is at the level of all SD main objects, and there will be two options, online and offline. The online option I'm not going to describe because it's the default option. This is the one you have been working on with connected apps. Now, today we will focus on the second option, the offline option. When we tell GeneXus now with this application, we are going to work on the offline modality. There's a third property or option to this property rather, which is inherit, which will be at the level of all SD objects that are not main, the rest of SD objects, and inherit will inherit the behavior of the object calling on it. So what happens when I go to my dashboard, my SD main object, whose default is support online, I set offline. So what happens is that a new object will be created. It's called offline database object. It will be created on the left under the node of my dashboard. And this object will be in charge of telling me the tables that will go from the server database to the local database, and which tables will keep registers for the next synchronization. So, how do we tell GeneXus which tables we want from the server's database to go to the local database? Because the server's database is not going to be a copy of what we have on the device for different reasons. Because of security reasons, I don't want my user to see all the tables I have in the server or all the registers. So I will filter the things that can be moved to the local database. So how do we tell GeneXus which tables we want to move? This is an example of an application of one event where we have a dashboard, and the dashboard calls three panels: WWSD sessions, speakers, and tweets. If you remember well, we have one object, dashboard. It's an SMI, so it has the property of connectivity support online. So I'm going to change that and tell him, now you will work offline. As from now, we change that property, and it's offline. So the panels, WWSD for sessions, speakers, and tweets, will inherit the behavior of the father, which is the dashboard, and will behave offline. And those panels, in turn, will access the respective tables. These are going to be the tables that we will copy on the local database of the device. Now, what happens if I say, I like it so far, but I want my customers to see the tweets only when I'm connected to the internet, because I just want to see updated information and the latest tweets. So what I will do is I will stand here on the tweets panel and tell it that it's going to behave according to a connectivity support online. So the tweets table will no longer be carried to the database of that is local of the device. Now, if we have a table that is taken to the local database but has a reference to another table in the system, the reference table will also be carried to the database. Now, what happens with this offline database object? It has navigation. And navigation, as you see, includes a synchronized event for each of the tables involved. And for each event, which is basically a for each in the table, we'll see what it applies. In this case, we see that there is a for each for the speaker table, and it takes this table with all its records. Now, if I say, I like it so far, but I don't want to take all the speakers to the local database. For example, what I want to do is take the best speakers, the smart devices, of course. So I will choose here under conditions, speaker topic, I will put smart devices. So navigation has changed. We add a constraint under the condition that I added. So from the speaker table, I only take and transport the list of speakers that speak about smart devices. Here we have a start event we can use. Let's talk a little bit about data synchronization, what I anticipated early in my presentation. Synchronization always is seen from the side of the device. So we say that we send data, we receive data from the customer's database to the server and from the server to the client. So let's look at this process separately. First, how do we receive data from the server to the customer? There are two ways, the automatic and the manual. And these properties that you see govern the behavior of the way in which I get data from the server's database. These properties are at the level of the offline database object, and we have data receive criteria. By default, it will be set as on application launch, and there are other options on the right. Then we have minimum time between receives. It will have a number. This means seconds, 600 seconds, 10 minutes. Or data receive granularity by row or by table. So what do the properties do? Starting with on application launch, I will receive data from the server to the customer when I do a launch of my application. And at the same time, when this minimum time is over. When I launch the application and that time elapses, I will receive the data from the server to the customer. How do I receive the data? Well, that's why the third property is here. Granularity tells me whether I receive it with a register or table. What is the difference? By register, the data, for example, the speakers table, some registers have been modified. Only those modified things will be sent to my local database. And by table means that it sends the whole table. The whole table, if there was a modification, they don't just send the modified registries, they send everything, the whole table to the customer. By table could be useful if I have very short tables, so it doesn't make sense to process modifications. I just send the whole table. Or if I have very long tables and I know that I modify all the registrations, so it's not worth doing the job or calculation. And this has advantages and disadvantages. By row, for example, what is the advantage of by row? The traffic in the communication server client is shorter because I only send the modified registries and not the whole table. And as an advantage, I need to know, the disadvantage is that I need to know what has been modified. And the same is true with the by table. I have less processing on the side of the server, but I have more traffic in the communication between server and client. Then we have after elapsed time, which complements the former. We receive data from the server to the client. Then, after the time has elapsed, since the last time I got data, that is the slight difference. And then the manual option. As you see, when I set manual, this middle part disappears. It doesn't make sense because I will be receiving data on a manual modality. How manual? Manual means through this method, which is synchronization.receive. I, as a developer, will determine when I want to receive data, and I can program this. This depends on the taste of the developer. So this has to do with when we receive data. Now, when we send data, we have the following properties. When connected is the default property, manual, and never. When connected, and we also have this minimum time between sends, which was introduced in GeneXus Evolution 3 as from upgrade 2. So when I set when connected, if I am disconnected in my application, I do certain actions, and these actions are recorded in a table in the order that I execute them on my device. And when I find the internet connection, all these actions take place in the same order and are replicated in the server following the same rule of order. Using this from upgrade 2 backwards and from upgrade 2 forward, we send the data if the minimum time has elapsed. And then I have the manual option, which is similar to the receive. I'm going to use the synchronization.send method, and I will be sending things whenever I want. And finally, the option never. You may wonder, why never? When do I want to use the never option? Never send data. What's that? Well, one example is personal financial applications where data is so sensitive that I never want that data to be sent out to the server. Another important clarification when you send data. If I want to do something on my device and send to the server, I will have to do it through business components. We are not taking into account the new or the for each. We use the components to send information to the server. Now, I want to talk about conflict that may come up during synchronization. GeneXus will solve those problems automatically. So stay in the room. The next presentation by Marcos Crispino will be how to synchronize offline applications. He will dwell on this more deeply. That's one thing. And finally, I would like to talk a little bit about what is the difference between online and offline? I've been working with Evolution 2. I have online applications. Now I want to migrate to Evolution 3 and work offline. What to do? It's very easy. First of all, you need to use the connectivity support property. From the main, turn it offline. This will generate a new object and so on. Then you have to choose your preferred way of sending and receiving data from server to customer, from customer to server. These are all the properties that I described to you with send and receive. Remember that it is necessary to use BC. That's a consideration to bear in mind. Then we apply filters. What are the filters? The ones I mentioned, the tables that I want to take from the server to my local device and what registers to synchronize. We apply the filters and we compile. And then we have the offline application running with GeneXus. So to sum up, thanks to GeneXus Evolution 3, we have more complete and more functional applications. We, as developers, come before new scenarios and possibilities to be developed. And as GeneXus does everything so quickly, it does things fast and easy. Let me stop here to invite you to think about the complexity of GeneXus Evolution 3 in terms of architecture. It would be very costly to do it manually, and with GeneXus Evolution 3 we have multi-platforms. It's just changing a property. We have an architecture that allows us to work offline with a database on the side of the customer, another on the side of the server. And it's such a complex world that cannot be done manually. So we have all the ingredients on the table to create first top quality applications. So I invite you to move on to Evolution 3 and offline applications. Thank you.